All right, so we are going to look at linear functions. Now, we looked at some linear functions earlier this year, um, and that was in the last chapter. We looked at two forms of a line, that was the point slope and the slope intercept form. Um, but we're only going to restrict ourselves to the slope intercept form. So we're going to be using the y equals mx plus b format for today's lesson. So the slope, when the last chapter I said, when you see the word per something, like miles per hour or cost per ticket or something along those lines, um, that number is going to be your slope. And the y-intercept, or the b, is what's called the initial condition. How much did they start out with? We had a problem a couple days ago in the assignment where they were talking about a girl adding $15 a day to her savings account, and they wanted to know how long it would take her to save a certain amount of money. And what they didn't tell you, though, is that she had started out with her savings account with $5 in it. So you had the $15 per week was the slope, but then there was $5 that was her initial condition. And you found that out by going backwards from her first week of having $20, even though they said that she was putting $15 a week in to the account. So that would be a case where there's some initial condition prior to something happening. So when we look at this section, like I said, we're just restricting it to the y equals mx plus b format. And so let's take a look at an example. So a farmer's market sells apples for $2 per pound. So I'm just going to put down the key points here as soon as I move my little markers so I can get at my bottom of my screen. Okay, so farmer sells apples for $2 per pound and oranges for $1 per pound. Oops. So he's got two things that he's selling, two things. Those two things could be the slope for both of them. It just depends on which one we set as our variable. So Marjorie has $10 to spend. You can't see this because I can't see it. Okay, so she has $10 to spend, and it says the function y equals 10 minus 2x. So that function right there, let's look at where these numbers are coming from. The $10 is this initial condition. That's how much she has to spend. And she's taking away whatever she's going to buy. In this case, because we have the 2 out in front of that x, we're referring to how many apples, with 2 p's instead of 3, that she can buy. And I don't know why that put a bunch of zeros there. I think I must have clicked to copy it. So it says the number of apples is the x and the oranges is y. And if you look out in front of the y, what's the number out in front of the y? what's the implied number out in front of the y? It's 1. And the 1 refers to the $1 per pound. So they want you to graph the function and interpret the points graph. So when we look at that graph, we're going to graph this equation, y equals 10 minus 2x. I could start up here and say my initial condition is 10, because that's what my y-intercept is. And then my slope is -2, so I can go down 2 units and over 1. So this would be the 0.18. This is the 0.010. If I go down 2 units and over 1, I get the 0.26. Down 2 units and over 1, 3.4. Down 2 units and over 1, 4.6. And down 2 units and over 1, and my points are way off, 2.8. And down 2 units and over 1, and I get about 5.8. How about 5? What did I do here? 2 and 0. That's why my points were off. You guys are got to stop me if you see me doing something wrong. Who else is going to keep track of me if you guys don't? So down 2 units and over 1, and we would be at 4.2. And down 2 units and over 1, and we'd be at 5.0. That's a little bit better. Okay, so we've plotted those points, and those points represent the number of apples and the number of oranges that we can buy. So we can buy 10 oranges. We can buy 1 apple and 8 oranges, 2 apples and 6 oranges, and so on. So when they ask you to interpret the points graphed, that's what they're asking you to do. Tell us what those points are. Now notice that I did not connect those points with a dot or with a line. And why not? Why did I not connect those points with a line? Okay, I'll tell you why not. These are discrete points. Can we buy a half of an apple that a farmer is selling? No, we can't. We have to buy whole numbers. We have to buy whole fruits. So we're only looking at the specific spots where we have whole numbers, because that makes sense in this case for what we're doing here. We're buying whole apples and whole oranges, and we're not buying a half of an apple and 9 oranges. It's just not going to happen. So this is called what's called a discrete graph. So it's the individual points. It's not a continuous line. Continuous is the opposite of discrete. If they just ask you to make a graph given an equation, if they say graph this equation, there's a couple different ways that you can do it. You can create a chart or a table and put values in here. Put 0 in for x, you get -5 for y. 1 in for x, -4. 2, -3. 3, -2. So you can make a table like that and graph those points. Or you can use the y-intercept and the slope to graph them. Y-intercept of -5, slope of 1, up 1, over 1. So whatever you are most comfortable with is how you can graph it. Some people would say, I'm most comfortable using Desmos. And that's fine as long as you know what Desmos is giving you. That they're giving you this line. In this case, they just ask you to graph this line, so it's a continuous line. But in the last case, you should only be graphing those individual points because it was a specific problem that talked about specific things. Okay. So either way, make a chart and graph it, or slope intercept and graph it. They do talk about continuous and discrete on page 298, and they say a continuous data set is something that you can have partial amounts of. So like if you're weighing something, you can go from a half an ounce to 3/4 of an ounce to a full ounce. But if you're talking about the number of glasses that you have in the cupboard, there's a specific whole number of glasses, and you aren't going to talk about that you have a half of a glass in the cupboard. Unless that glass is half full, then you can talk about whether it's half full or half empty. Da-da-da. You guys are really dead this morning. Okay, you just want to get on and get out of here. So, one more example. Either that or you just put me on and you went back to sleep and you're just playing it out until I get done and say what the assignment is.
No, I'm doing my homework right now.
Oh, okay.
Guessing hopefully that it's the right problem.
Yeah, and if it's not, it doesn't matter because then you're just doing more problems than you have to do, right?
Exactly.
And you just get more practice at it. Okay, so a store sells assorted nuts for $5.95 per pound. So per pound, that's representing the slope. So $5.95 times X. It doesn't say that you start out with 5 pounds or anything like that. So you're assuming that they didn't give you an initial condition. So the y-intercept is 0. If we plot those points, it would make sense that if you buy 0 pounds of nuts, you pay $0. There's that direct variation. It's going through the point 0, 0. If you buy 1 pound of nuts, you're spending $5.95. If you buy 2 pounds of nuts, you're spending $11.90, and so on. Can you buy a half a pound of nuts? You can. So is this graph continuous or is it discrete? It is continuous, but you're only going to be talking about the points that are in the first quadrant because you can't buy a negative pound of nuts. So it is continuous and it goes up. Our labels that we would put on here is this is our pounds of nuts.
Do we have to graph it or can we just put it in the chart?
They want you to do both actually.
Okay.
In some of the problems. If they don't tell you, you can do either one. This is going to be the cost. Okay. So yeah, so if they just tell you to graph it, you can graph it either way. If they give you a chart, they want you to fill out the chart. If they give you a graph it on their graph. Make sure to put these labels in here though, of what your X and your Y, what your dependent and independent variable are standing for. So Gianna, what are we going to do for our assignment?
What we should do or where we are.
No, what should we do?
We're at 301.
Yeah, what should we do for the assignment?
1 through 5 on that page, and then on
Yeah, just said
303,
nothing.
12 through 15.
15 or 16?
15.
Oh, I think we should go
16 has
through.
too many steps.
I think we should go through 16. So 301.
Fortnite, guys. Or we could.
Oh, no, I said 15.
Gianna, you could have said
No, not
That could have been
16.
an option.
We're going to go through 16. Yeah, 12 through 16. And actually, it's how many problems is that? 1, 2, 3, 4, 5. 5 problems where some they're asking you to graph. 5 problems on the second page. 1, 2, 3, 4, 5 problems on the first page. A total of 10 problems. 6 of the 10 problems you can graph using the slope intercept. So if you look at number 1, it says graph the function y equals 4x. You can put a point at 0 because there's no y-intercept. So 0, 0 would be 1 point. Go up 4 and over 1, put another point, draw your line, you're good to go. 2 is very similar to that. So yeah, these 10 problems will work for me. I will tell you that I intend today to gather some work around for those of you that get bored over Christmas break and just want to, do some math sometime. I will have some stuff posted that you can do. It is not mandatory that you do it. It is optional. It's if you get bored and you don't want to forget what we've gone over in math, you can remind yourself. So that will
Don't
be.
tell my mom that is up, because she will be telling me to do it.
Oh, well, I was going to send out an email to all of my parents and say, hey, there's optional stuff.
Yeah, it's kind of.
Yeah, no, I'm going to send it out to the parents to let them know that you have optional stuff for when you get bored, because you will go up to them and say, I'm bored. They have to have something to come back at you with.
Had more assignments.
No, me and my brother are making ornaments. We're not going to be bored.
I'll be in Disney. I will not be bored.
Oh, wonderful. I'm glad. I'm glad you won't be bored.
I will just always never be bored.
I'm just giving something to the parents that when the kids come up and say, I'm bored, they have something to give to you to say, well, here, go do some math problems. And you can come back,
Thank
with.
You, Mrs. Reed. I'm going to go.
Oh,
have a good day.
Bye. All right. I'm done, guys.
Thank you, Mrs. Reed.
See ya.
Mrs. Reed?
Yes, Will.
Can we use Desmos to graph these first 3?
You can, as long as you know what you're interpreting on those. Like, what is the y-intercept? Match that y-intercept up with the equation and the slope. Make sure that you're understanding those 2 concepts. You're more than welcome to use Desmos. So,
bye-bye.
Bye. See you, Ian. And Nora, you're the last one on almost.
All right. See ya.
See ya. Nora, did you fall asleep?